All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 79 is on the screen. Let's get started, please. That shouldn't take you long. And get a Cornell note going because we're moving on today. Today's going to be an interesting session. I just want to make sure everybody's ready to move on. We got a couple more rules to be introduced. Let's go. I mean, why not add to our formulas, right? Let's go. Let's go. I'll give you some time for that. All right, so you made a table, you sent that in, and what kind of probability is this? Tell your neighbor, please. Probability. Patent. What kind? Classical. That is correct. All right. Copy the agenda, please. Warm up number 79. Today we're moving on to addition rules of probability. Nice. Home plate page 206 to 207, numbers 1 through 7 odds. This time I did not include the screenshot, but you have your textbooks at home because today it's going to be a lesson pretty packed for the time that we have here. So stay focused. Let me send that to your screen. There it is. Get a Cornell note going. All right, here we go. I can identify and compute basic probability. So even though we already are past the introduction, we're still on basic probability, and we already know the three different areas of probability. Remind your neighbor what they are. What are the three different probabilities that we've been looking at? Three different probabilities. Yeah, by now you should be experts because you actually made a poster and a video and explained your activity. So yeah, we have classical, empirical, and subjective. So once we got through this portion, like I said, we're about to get into rules. So let me pause some of that music back there. And the rules start getting a little bit, how shall I say, funner. Yeah? So let's start with the word exclusive. Think about the word exclusive. Don't copy that. Just think about it. Tell your neighbor what that means. What does exclusive mean? Let's say you are an exclusive person. What does that mean? Talk it over to your neighbor. Exclusive. Especially those of you in advanced language arts courses, you should know what exclusive means. All right. Exclusive. Here goes from the dictionary. It says exclusive, excluding, having power to exclude, limiting or limiting, possessing control, excluding others from participation, a little bit more on the secondary and a negatively, snobbish or aloof, and so on and so forth. So basically, anything that's exclusive has to be pretty much standalone because they don't really include a lot of people. And I'm going to say I'm a little bit like that in a sense. Ever since I was a kid, I remember whenever I encountered someone that was around, for example, bullies, I can't stand bullies. So don't even come close to me because we'll put a stop to that big time. I mean, I was a little kid, but I didn't care if you were like a big bully. I was like, have you seen those little chihuahuas that start barking at like German shepherds? That was probably me when I was a kid. So bullies, no. And that's why I can count my friends ever since junior high, high school, and up to now with one hand, and I have a finger that is left over. Why? Because to get into my circle, I'm very exclusive. Pump fake, let's go. Diego. All right, so with that said, events, write this down. Events, there's two types. Mutually exclusive and not mutually exclusive. Mutually exclusive, not mutually exclusive. Mutually exclusive and not mutually exclusive. So think about it. Now that I explained what exclusive was, if you have events that are mutually exclusive, tell your neighbor, what does that mean, mutually exclusive? What do you think it means? Mutually exclusive. And then we'll ask someone that we haven't called on in a while. Mutually exclusive. What do you think it means? Since you already talked about it with your neighbor, what do you think it means? Oh my goodness. Okay, once again, guys, I mean, if you guys make it big out there, come hook me up some technology, please. Pretty please with the cherry on top. All right, mutually inclusive. Jaden, what does mutually inclusive mean? What do you think? An event that what? Oh my, oh my goodness, you just like. That can't happen at this. Whoa, let's go. Write that down, please. Events that cannot happen at the same time. Man, you know what? Extra credit. Write it down on your paper. Put extra credit, and I'm going to give you some extra credit. Yeah, I'll sign it later. That is correct. Events that. Sorry, you get the credit. Let's go. Events that cannot happen at the same time. That is correct. So write the definition for not mutually exclusive. All right, pass someone. Yeah. My goodness, you guys are like on the money. Yes, events that can happen at the same time. So let's just be clear. We're talking about events, okay? So before I elaborate on mutually exclusive, not mutually exclusive. So whenever we did the classical probability with a die, remember that they were outcomes, and then they were probability, and then we did outcome 1, 2, 3, 4, 5, and 6. So then, if I was to ask you for you to bet on a number of these, then you would bet on 1. Could that happen at the same time as 3 or as 4? No, that's what mutually exclusive means. That's an event, and it happens by itself. Now, another example would be this one. Have you seen these before? The roulette? There's only 2 colors, well, 3 colors with a green, which is the double zero. But the rest of them, they're either red or black. And I don't know if you've seen in movies when people get there with a stack of cash and they're like, put it on red or put it on black, right? Now, could you put it on both? Yeah, but it, you know what I'm saying? It's basically, it's a wash because, so it can't happen at the same time. So that's an example of that, all right? So let's focus right now on mutually exclusive, okay? So here we go. Write this formula down, please. Mutually exclusive events, addition rules. Addition rule number 1, it says, when 2 events, A and B, are mutually exclusive, the probability that A or B will occur is P of A or B equals P of A plus P of B. Write that down, please. Let me send that to your screen. I'll give you some time. And here's the rule. P of A or B equals P of A plus P of B. Did I send that to your screen? Yes. All right. So let's start with an example. Here we go. Example Q. It reads, writing pencils down, look up to the screen. A day of the week is selected at random. Find the probability that it is a weekend. Okay. So think about it. Weekend. What days are part of the weekend? What is it? Okay, yeah, so therefore I would start my formula, instead of writing P of A or P of B, I would start P of Saturday or P of Sunday. All right, so copy that one, example Q, copy the problem itself, and then get started with your formula like this, and then we'll continue together as soon as I see you guys copy that. All right, so according to our formula or our rule, P of A or B is P of A plus P of B. That's what we need to follow. So If that's true, what would I write to continue my formula? Tell your neighbor, what would I write next? Not numbers yet. First, let's write it in words. What would I write next? Fernando, pass someone? Diego. Yep. Pretty much straightforward, yes? All right, so P of Saturday or Sunday is, so tell your neighbor the probability of a Saturday for the week. What is the probability? Pass someone, Diego? All right. 1/7. How about of Sunday? Therefore, the probability of Saturday or Sunday is 2/7. Kate? Yes, from 1 to 5, I'll come to where you up to right there. Okay. So, the rest of it is pretty much just different types of problems that look like this. So before I move on to the next one, send me your notes really quick. I want to see what you did. All right, so once again, P of A or B is P of A plus P of B. So we have P of Saturday or Sunday is P of Saturday plus P of Sunday. Therefore, this is 1/7 plus 1/7 is 2/7. Okay. Example, super Q. Right, super Q. You're not going to copy the whole thing, but let me read it out. Let me pause the tunes in the back. And it reads, Imperial County has 17 coffee shops. That's how many I counted. Maybe there are more. So, you might know of more. I counted 9 Starbucks and 8 independent coffee shops, such as 316, Brick House. There's 2 Hope Cafes, one in Calexico and El Centro. There's a Surf and something, I don't know what it's called, but there's this guy in a van, like a 70s van, that goes around and parks in different parks, opens up the side, starts selling like espressos, and I'm like, oh, okay. Pepper Grime, there's that place, it's over there by, in front of the El Centro Regional, like right across, it's a little hidden place. It's really good, by the way. I like the vanilla breve, I think that's what it's called, and the lime, and they have a nice lunch sandwich. Anyways, and we got Sweet Nothings. There's that one right off Main Street, and I think it's 6th Street, Main and 6th in El Centro. And basically, if you're one of those that can't have sugar or anything of that kind, they have all those pastries there that are sugar-free. So I'm like, okay. And then I saw a new one pop up in Brawley called Honey Buzz. I don't know if you guys heard of that one. So anyways, it just opened in Brawley. And I think there's a couple more. We're also having some other ones that are about to open in El Centro, but I counted those many as so far. So we got 17 coffee shops, yes? Therefore, it reads, if a person selects one shop at random to buy a cup of coffee, find the probability that it is either a Starbucks or Pepper Grind. Therefore, find me that probability, please. Go. All right, who went last? Areli, have someone? Joseph, help us set this up. Starbucks or so therefore okay, so therefore P Starbucks is answer 1017. Hands if you got that. That is correct. From 1 to 5, I'll come to you with a different view of this. Okay, let's do one more. Send me that, please. Example, Mega Q. For this one, just copy the data. U.S. Steel, 110. Alcoa, 750. Bayer Material Science, 250. Just copy those three data for that example, and then answer the question. So let me read the entire problem. It says, the corporate research and development centers for 3 local companies have the following numbers of employees. So U.S. Steel, Alcoa, and Bayer Material Science, as they are. If a research employee is selected at random, find the probability that the employee is employed by the U.S. Steel or Alcoa. So find the probability, please. Let me send you the screen, and then send me that as soon as you are done. All right, check with them, see what they got. They should have a total at the end. What is that total for P of U.S. Steel or Alcoa? What was that total? Joseph, pass someone. Chelsea, total. Chelsea, total. 1,100 and what? And 10. Okay. So what is the probability for U.S. Steel and Alcoa? 860 over 110, or 86 over 111. Simplified. Yes? All right. So far, so good, yes? All right. From 1 to 5, how comfortable are you with mutually exclusive? Yes? Okay. Shall we move on to mutually non-exclusive? All right. Copy this, please. If A and B, this is addition rule number 2. If A and B are not mutually exclusive, then P of A or B equals P of A plus P of B minus P of A and B. You're like, what? Copy that, please. All right, here we go. So that's our addition rule number 2. This is for non-mutually exclusive. There you go. Example 2Q reads, look up to the screen. On New Year's Eve, the probability of a person driving while intoxicated is 0.32. The probability of a person having a driving accident is 0.09. The probability of a person having, and the probability of a person having a driving accident while intoxicated, so what do you guys notice on the last one? That's what? Both two together is what? 0.06. So therefore, what is the probability of a person driving while intoxicated or having a driving accident? This is what I want you to do. On example 2Q, write down what I underlined, please. Write intoxicated, 0.32. Then you're going to write driving accident, 0.09. And then the last bit of information is driving accident while intoxicated, 0.06. The question is, what is the probability of a person driving while intoxicated or having a driving accident? This is for non-mutually exclusive. So let's write our formula. P of A or B is P of A plus P of B minus P of A and B. So, what is the question? What is the probability of a person driving while intoxicated or having a driving accident? So, let's write P of, instead of A, tell your neighbor what to write instead of A. Look at the question. What do I write instead of A? Dylan! Yes, so let's write int just for intoxicated. Or what would be our B? Lenny accident. So I'm just going to write ACC for accident. So therefore, we would write P of int for intoxicated plus P of accident minus P of intoxicated and accident. This one's straightforward, so you just look at the data. Do you have data for P of intoxicated? What is that, everyone? 0. What? 32 plus .09 minus, is there one that has both of them? Yeah, 0.06. Therefore, calculators calculate 0.32 plus 0.09 minus 0.06 is 0.35. And that is the probability for a person driving while intoxicated or having a driving accident. I'm sending you the screen so you can send me your notes. Give me a second. So before I go to the next one, I just want to make sure that we're clear in regards to the formulas. Look at the previous formula and the current formula. So you never the only thing that differs from the mutually exclusive formula to non-mutually exclusive without looking at your notes. What's the only thing that differs? Dylan, pass on. And I'm going to pass it back to Dylan. Dylan, what's the only difference from the previous one to that one? Yes, subtract the A and B. That's the only thing that's different. And what does that mean? That you need to look for the data where both intersect. So for example, look at this next problem. The setup's a little bit different. So write this one down on your paper, example 2 super Q. And it reads, in a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, find the probability that the subject is a nurse or a male. Copy the entire problem on your paper, please. Let me send that to your screen. All right, once again, it reads, in a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are female. If a staff person is selected, find the probability that the subject is a nurse or a male. So notice on this one, the question involves 2 not mutually exclusive events, which means we need to know where they intersect, right? So for these kind of problems, you need to set up a table so you can organize your data. So first of all, start off, what are they talking about? They're talking about staff, aren't they? What kind of staff are they talking about in the hospital? Nurses and? Very good. So let's write staff, nurse, or nurses, physicians. All right, and what else are they talking about now? Talking about in regards to the different scenarios, that 7 nurses and 3 physicians are what? Female. So they're talking about male and female. So let's write that down. Female, male. So of course, in order to find our probability, don't we need a total of totals? Yes, total of totals. Okay. Let's start gathering data. 7 nurses and 3 physicians are female. 7 nurses and 3 physicians. All right, what else? It says a hospital unit, there are 8 nurses. So that's the total, right? So that goes where? Over here, which means 7 are female and what? 1 male. There it is. 5 physicians. The total of physician is 5. So if there's 3 of female, that means there has to be 2 male. Okay. So what's our total here? 13. Total here are females, there's 10, and total here are males, that's 3. All right. Do we have enough information to set up our probability? Yes? So, let me scoot up. P of A or B is P of A plus P of B minus P of A and B. All right. So, turn to your neighbor, let them know what P of A, what are you going to write for P of A? Dylan, pass someone? Jaden. M. Very good. Nurse or no, what are they asking at the end? Male, yes, male. That means P of nurse plus P of male minus P of nurse and male. So, what is probability of P of n? Tell your neighbor, P of n. What would you write for P of n? Probability of being a nurse. Pass someone, Jaden? David? 8 out of what? That is correct. Plus, how about P of male? 3 out of 13. Minus P of a nurse and male. Nurse and male. So it's what? No, where do they intersect, guys? At 1. That's when they're both at the same time. You guys see it? Yes? So it's 1 out of what? 13. Therefore, the probability of, question was, the probability of a person selected being a nurse or a male is 10 out of 13. Yes, no, maybe so? All right, send me your screen, please. Give me a second. I mean your notes. All right, so today we saw mutually exclusive and not mutually exclusive. By now you can know the difference between one formula to the next. That's how your home plete's going to go. From 1 to 5, how comfortable are you with these 2 rules for today? Addition rules, 5 fours, 5 fours, okay. All right, I'm going to stop right there. Those of you that are following along on YouTube, just go and get some extra practice for addition rules for probability, and just do some extra practice. And for the rest of us, just a reminder, our home plate for tonight is on pages 206, 207, numbers 1 through 7, odds. I'll stop right there. Enjoy. Bye.